Hi, this is Stephen Brower. This is meant to be a sort of an aside to the lecture on graphs. It's really only a small point, but it's just something I kind of wanted to go through in terms of a way in which a graph can be used. Now, what's going to follow is a huge oversimplification of how a graph can be used. And so, I've boiled some things down so simplistically. Well, anyway, meant to be a rough idea. Okay, so one thing a graph can be used for is for, well, modeling a neural network. So in the brain, the information that we retain is held in neurons, and these neurons are connected together through a series of pathways. And then reasoning in the brain is sort of following pathways to go through these neurons to connect this information together. So with artificial intelligence, we can use a graph to simulate the brain, where the neurons can be simulated in terms of the vertices or the nodes in the graph. So that's what holds the information. The pathways, that can be the edges and the links. Well, actually, the edge or a link would be connecting two vertices together, and then a pathway would be a series of edges to collect a series of pieces of information together. So then the reasoning that, since our brain uses, or the algorithms that are actually used in our brain for reasoning, can be simulated by the algorithms that are used to create these connections and then traverse the graph of that connection. Okay, so what I want to do is sort of a silly example coming up, but it's a kind of a connection thing. So what I want to do is I'm about to show a word and say a word. And what I'm hoping is that you'll start to have in your mind, maybe one idea, two ideas, three ideas, all connected to this one word that I'm going to show. So in a few seconds, I'll present that word and say the word, and I'll take a moment before moving on to the next slide. Orange. Okay, so with that, now some of you may have read it before I said it. Some of you may have heard it before I read it. And so what I'm just representing here is that the text that was on the screen, orange, in terms of when we think of orange, we actually can think of the text, or we can think of the sound orange. So we hear orange. Now, and one can lead to the other. We can hear orange and we can think of the text. We can see the text and we can think of what it sounds like. And all I'm doing at this present moment is just really addressing two things: the series of letters, the text, and then the sound, orange, the way in which it's pronounced. Now, from whether you read it or heard it or both, one thing that some people may have thought of is the color, orange. And so what I'm showing here is sort of the connection that from either the hearing it, thinking of the color, or the reading it, thinking of the color, but that sort of a connection can be made between the text and the sound and the color. Some of you may have thought of the fruit. So on hearing orange, thought of an orange, the fruit. Reading orange, thought of an orange, the fruit. Now, if you're thinking of the fruit, you may think of the color. If you're thinking of the color, you may think of the fruit. So even, possibly for some, the two things were thought of. The color, then the fruit, or the fruit, then the color. And so, again, in terms of the brain, these things here would be held in the neurons, and then the connections between them, those would be really connections that exist between the neurons, and then the pathways that we establish, and sometimes these are pre-established, and sometimes we will go and connect them, but that would be how the information then gets connected together. The next two things I want to show in terms of other things, in terms of orange, might be maybe a little bit silly, but there have been a number of football games that are on recently. And although they didn't get a bowl game, the orange is the name of the Syracuse football team. And so someone who is very familiar with Syracuse football, maybe on hearing orange or reading orange, would have thought of the orange, the name of the Syracuse football team. Those into car racing, they have thought of Team Orange, that the connection might have been made, thinking of that. Well, there's a whole bunch of things, and I'm just going to show them kind of all at once, that all of these orange things may have come to mind, again, either second or third or fourth. Each of the pictures that are here then could be sort of nodes in the graph, and then the connections can exist. But the orange clownfish, orange goldfish, the orange bowl, an orange tabby cat, orange blossom, orange crush, orange juice, orange marmalade, orange state, orange is the new black, orange butterfly, orange chicken, orange tree, orange slice, orange peel, orange pumpkin, orange vest, orange zest, orange pepper, orange sky, orange Uggs. This is going to take a little explaining. That's Jesse Tyler Ferguson from Modern Family. This is in a Voya commercial. I don't know if you see right here, there's the orange bunny right here. And the two of them actually have a funny exchange on where are you, orange? Okay. Anyway, the point I'm trying to make, but possibly not well, is that if we're trying to sort of simulate the way that we retain information, connect things together, we would then establish, if we're trying to do, a system, sort of links between all these things. And all these things have some connection to orange, either a direct connection or an indirect connection to orange, but there is a connection to orange. And so if we try to come up with artificial intelligence systems and we're dealing with information, we can use graphs as a way of storing the information and then connecting all of the information together. Okay, one last orange, and then that will be it.